All right, well, I have the top of the hour and we will go ahead and just get started. I know there are probably going to be some people rolling in a little bit late, but just to get started with a little bit of housekeeping, this is a webinar about the hidden gems in the Oracle Cloud. I am Todd Sharp and I will be walking you through this presentation today. We have an hour together. It is 1 o'clock my time. I'm not sure what time it is for you, but I do appreciate you joining me, whatever time it is. And this session will be recorded. So if you miss part of it or you have to leave or you know someone else that may be interested, we can provide you with the URL later on. Again, I'm Todd Sharp. This is Hidden Gems in the Oracle Cloud. We're going to talk, we have an hour together. We're going to probably talk for about 45, 50 minutes and leave some time at the end for Q&A. So you can please go ahead and put any questions you have in the chat and we will take a look at those at the end. So let's get started here. This is Oracle's safe harbor statement. Please do not buy anything or make any decisions based on what you hear from me today. This is me. I am a developer advocate at Oracle. I previously worked at AT&T and a consulting firm called Booz Allen Hamilton. And I have 16 years of full stack experience. I am a developer first and a developer advocate second. So I have a lot of experience with Java and JVM languages like Groovy and Cold Fusion way back in the day. But I also have a lot of experience with the other side of things, the front end, and JavaScript, and as well as Node.js on the server side. So I have a full range of experience from many different languages, and of course you can add SQL into that as well. I want to make a promise to you, and that promise is this. In the next 60 minutes, you will learn about an Oracle product, service, or feature that you never knew existed that will make your job easier. Hopefully and likely it will be more than one, but I promise you there will be at least one thing in here that you will learn about that you did not know about before. Before we look at those, let's take a very, very quick look at the familiar. And what do I mean by the familiar? Well, there's a lot of things in the Oracle Cloud that are very familiar. Bare metal instances, VMs, autonomous database, API gateways, object storage, just your very kind of basic infrastructure type things in the Oracle Cloud, Kubernetes engine, MySQL as a service. All of these things are familiar, and that's not what this talk is about today. This talk today is about those not so familiar services. We may take a look at one of the familiar services, but we'll look at some of the not so familiar aspects of those services. And like I said, you will find out something that you did not know existed, maybe a feature that you didn't know was there, and you're going to say, hey, that's going to make my life a little easier. So let's get started because we have a lot of them to cover. The first one I want to take a look at is autoscaling. Now, autoscaling is one of those things that you may have known existed already. But if you knew it existed already, you probably knew of it more in the context of metric-based autoscaling. So your typical type autoscaling where you have a high CPU utilization, you have high resource utilization, and you want to scale an instance group based on that utilization. What you may not be as familiar with and didn't know existed was about sometime in June, we released a new version of autoscaling, and that is schedule-based autoscaling. So this gives you the ability to anticipate demand, and you can even save costs by turning things down when not needed. What do I mean by that? Well, think about your average kind of development team. I've been on many of them over the past 16 years, and a lot of times our teams had both a test and or a QA environment, demo environment, whatever you want to call it, an environment where it was not quite production, but we definitely needed it up and running to give demos of our service, to give things like that. Well, is that something that needs to be running 24/7? Probably not. I mean, usually our teams were US based, a lot of times in the same time zone. Obviously, this isn't going to work for every single project and every single team, But in a lot of cases, your team is going to be centrally located. And let's say maybe you only need your demo environment to be running from 8 a.m. to 5 p.m. Well, actually, if you're working with many developers, it's probably more like 10 a.m. to like 8 p.m. I mean, developers aren't typically known for being early risers. But anyways, no matter what your schedule that you need is, you can schedule this instance pool to be turned up and turned down based on a given schedule. Now, to do this is really, really easy. There are a few steps. If you look back at the URL that I have on the bottom of the page there, you can't see it fully right now. But if you go to that link, you will see a blog post that kind of walks you through this all in great detail. In fact, many of the topics that we're going to cover today, there is a subsequent blog post that you can go read about to get further information. And the last few slides here has all of those links in one place to help you out with that. So let's talk about schedule-based autoscaling. So the first step you want to do is you want to create an instance based on your application image, right? So if you see there, number 1 down at the bottom, I have created a custom image based on my demo application. So I have an application, it is deployed to this VM, it's all set up to spin up Tomcat, whatever it has to do, the application's running on this instance. You create a custom image from that instance, and every time you create a custom image, what happens is the entire set of pre-installed software, whatever's installed on that machine, will be available in subsequent instances created from that image. So it's a nice way to take a snapshot in time of your image and reproduce it later on. So I have an instance here created from a custom image, and what I do is I go to More Actions and I click Create Instance Configuration. I give that instance configuration a name, and then from the instance configuration details, I click on Create Instance Pool. Now, an instance pool is just what it sounds like. It's just a pool of instances, all with a common configuration, in this case, our demo application custom image. When I create the instance pool, I give it a name, and I select the number of instances. In my case, if you weren't aware, you can create a instance pool with 0 instances in it. So it's just a pool that contains the configuration. It can be scaled later on. So I create an instance pool with 0 instances. From there, the instance pool details, I can select Create Autoscaling Configuration from More Actions. Then I simply give that Autoscaling configuration a name, and I come to the second step of that Autoscale wizard. Now, this is, if you're familiar with metric-based autoscaling, or if you're not, this is where you choose what type of autoscale configuration you want for this particular config. So again, if I wanted metric-based, if I wanted it based on CPU utilization or memory utilization or any other possible metric that is tracked, I could do that. But in this case, like I said, we're going to do schedule-based. So we select schedule-based, and we simply we can create some autoscaling policies below that. Now, you can create several autoscaling policies, however many you need for this particular configuration. So in my case, I have 2 different policies. I have a policy to turn everything in that pool up, or really scale the pool up to a size of 1. And I want that to happen, as I said, maybe at 8 a.m. Whatever time I need to do that, I can create the target pool size, give the policy a name, and note that all the times are in UTC, so you have to make any kind of corrections or adjustments to accommodate that. But at that point, I just use a standard type cron schedule, and this policy will be applied at that time on that schedule. I can add another policy if I, like I said, wanted to turn it down, scale the pool down to 0 instances at 5 p.m. or whenever my team quits for the day. I can do that. Now, you could use this in conjunction with demand. If you know every Friday your demand is higher because whatever reason, you could schedule this, schedule your application VMs to scale up to 10 instances if you wanted to. It's just a nice way to schedule your auto scaling for your instance pool. I should note, I probably will get in trouble for mentioning this to you, but I should note, you can create a schedule-based auto configuration to scale an instance pool from 0 instances to 0 instances. Now, why would you want to do that? Well, because, as we'll see later on, when your schedule-based auto-scaling event happens, a cloud event is triggered, and you can take certain actions based upon that cloud event. Now, if you wanted something to happen on a given schedule and you did not have any other way to schedule it, this might be a somewhat little hacky way of doing it, scheduling from an instance pool to scale from 0 to 0 instances. That way you get that event fired on that schedule every single time. You did not hear that from me though, so we'll go on to the next topic. And the next topic is notifications. Now, notifications are one of those things that we might take for granted. They might seem a less sparkly, less interesting feature, but to me, I think notifications are really cool because they're really ingrained in so many other services and products in the Oracle Cloud. There's so many integrations and there's so many things you can do when it comes to notifications. In fact, I wrote a gigantic blog post. If you see the link at the bottom of that page, it pretty much has all of this and more inside of it. But it's a really in-depth, detailed look at notifications in the Oracle Cloud. So notifications. The first thing you do is you create a topic. And once you have created a topic, you can create a subscription to a topic. And then you choose the protocol with which the subscription should be handled. And the different options for protocols are email. With a little hacking, this can also be SMS. So I'm not sure if you are aware, but just about every single mobile phone on the planet has every carrier on the planet has a way to send an SMS to your phone via email. So if you're using Verizon, for example, your mobile phone's email address will be your telephone number at a very specific Verizon domain. And you can Google this, you could figure out for your specific mobile phone provider what your email address is to send an SMS to your mobile device. So I do believe native SMS support is coming in the future. I don't know if I'm allowed to say that, and I don't know when it's coming. So in the meantime, if you wanted to send an SMS, you can do it with email. You could also do it with PagerDuty, which we'll see in a little bit. HTTPS, if you want to work with webhooks, you can create a subscription that calls a webhook. And Slack, you can create a custom Slack application that receives notifications from a topic. Now there's 3 different ways to trigger notifications in the Oracle Cloud. One way is through events, one way is through alarms, and the other way is manually. Let's take a look at that a little further here. So event triggers, things like compute instances being turned up, databases being backed up, networks being scaled, things like this. They all fire events which will trigger notifications and then ultimately subsequently call your trigger your subscription to be called. Alarm triggers, so compute instances going into alarms because the CPU is greater than 90%. These will trigger notifications. If you wanted to make sure, or for example, the auto-scaling configuration that we looked at in the previous topic, this will trigger a notification. All these things are things that you could then do, take actions with. Manual triggers, this is either via the SDK or the CLI. You can create your own topic, do whatever you need to do with it. Let's say you wanted a topic for when new users were subscribed to your application, when new orders were placed over a certain threshold, things like this. You could use the notification service for anything you need to use it for, and then trigger those notifications at will through the SDK, in your application, or through the CLI. So how easy is it to use notifications? The first thing you're going to do is create a topic, give it a name and a description, and create a subscription. You'll choose your protocol from the drop-down menu, and depending on the protocol chosen, maybe provide additional information. For example, if we're talking about a Slack integration, you would provide the Slack webhook URL endpoint, and from there, you can start receiving notifications. Now here's just some various examples of notifications I have received from the notification service. On the top right-hand side there, I created an example of creating GitHub issues directly from notifications. At the bottom, I have a PagerDuty endpoint that's set up and can actually receive voice calls from notifications or SMS notifications. The SMS in the middle there on the left-hand side is sent from PagerDuty. And in the top left-hand corner there, that's an example of a Slack message that Slack application that received a notification from my notification service. Here's an example of using the Java SDK to publish a notification. Again, like I said, if you, for whatever you need to do, you can create your own notifications, your own topics, and your own subscriptions, and publish and subscribe as needed through the SDK. Let's talk about serverless functions. Now, serverless functions are one of the familiar services. Hopefully, this is nothing new to you, and you are well aware of the fact that Oracle Functions exists, which is our serverless offering in the Oracle Cloud. If you're not, let's talk later on, and I could probably tell you more about that. I would love to tell you more about that. But let's talk in particular about one thing that seems to be a surprise to many, many people that I talk to when it comes to Oracle's serverless functions, and that is the existence of logging. So when you create a serverless function, you deploy it to the Oracle Cloud, and then you try to invoke that serverless function. Many times, what you're going to get back when you're developing this function, if you're kind of in the development process, you're going to eventually get back a 502 error. And it's going to say 502 function failed. And you're going to say, great, function failed. No problem, we can fix that. What exactly failed? And you're not going to know because you have not set up logging. So the first thing you should do when you're setting up serverless functions is to set up logging. Now, this is disabled by default. Obviously, we don't want to make you incur any charges for things like object storage or anything else. And we can't make assumptions on any third-party services that you're going to use. So by default, this is disabled. You can enable object storage as an endpoint for your serverless functions logging. However, I don't really recommend that because it's really can be kind of slow. So, I mean, we're talking like 10, 15 minutes before your log messages actually make it into object storage, which unless you have a lot of time to sit around and wait, it's not very conducive to rapid development. Now, you can also use third-party services by providing what's called a syslog URL. And you can configure this all via the console UI or via the CLI. So if you're in the console UI, what you would do in your serverless application is click on Edit, and you can select your logging policy. So you can, again, log to object storage, or you can enter a syslog URL. And a syslog URL is essentially just a socket server URL that you can point your serverless function to that will receive your log information. Now, if you look through our documentation, they mention a service called Papertrail. And if you go to papertrailapp.com, you can sign up for a new service or a new account, and you'll receive a customized URL. As you can see on the left there, it's under log destinations. And you'll have this custom URL with a custom port that you can come over to serverless functions and you could paste that in. You could also update it via the CLI, whatever you want to do. You save your changes, you invoke your function, you go over to the Papertrail dashboard, and you see your serverless function output in the Papertrail dashboard. Really nice, really handy. At one point, about a month and a half ago, I realized that this is just a socket server. I can build one of these myself. So I did that. I created my own socket server, and it's on GitHub. If you look at the blog post at the bottom of the page there, you can download it and run it yourself. You do have to make sure you have to make sure that your port on your router, so if you're using in this case port 30,000, you need to make sure that that's open and exposed. But other than that, you use your public IP, you use port 30,000 in this case, you paste that URL into your serverless function application, and you can get logs directly in your own console right from your serverless functions. Really nice, really handy. I like to, as you see here, I like to open it up in kind of a split screen view in my terminal where I can invoke on the left-hand side and see my console output on the right-hand side. You could also deploy this in a VM in the Oracle Cloud if you wanted to do that and SSH into it. If you didn't want to worry about opening ports in your own router, fire up a VM, run my serverless logging application in the VM, SSH in, and just view the output directly there. That's one possible solution. And it'll run on any operating system. There's a Mac version, a Linux version, and a Windows version, as well as a jar file that you could just run straight up as a jar file. So see that blog post for more information, but it's a really, really handy way. Coming soon, there is a OCI logging service that is being worked on and is in limited availability. It will look like this. You may have heard of a similar service at some of our competitors, but this is our answer to that, and it is coming very, very soon, so keep an eye out for that. It'll be really nice because it's that native integration. You can set it up, and all your logs will be available and searchable directly from the console UI. Let's talk about cloud events. I have talked about these, I've mentioned these a couple times so far, but I have not really gone into really big detail about them. So what are cloud events? Well, they follow the CNCF Foundation, Cloud Native Computing Foundation's industry standard cloud event format, right? So services emit events, and this could be either a resource, things like compute nodes being added, or this could be data, things like object storage, buckets receiving items uploaded to them. What you do is you create a rule, which for example is when this object is uploaded to a bucket, and then you create an action. You can call a function, you can do something when that happens. So it's basically just this event format that allows you to create rules, to listen for events, and take actions based on those events. So here's just a little diagram of how that looks. You have your resources and your events with the rules, and they can take some actions. Well, what kind of actions can they take? They can send notifications to a notification topic. You can publish these events to a stream via the Oracle streaming service. And I probably should have included Oracle streaming service in this presentation as a hidden gem, in case you're not aware of it. But hopefully you all are well aware of the Oracle streaming service, which is a fully Kafka compatible message queue type system for pub sub of messages. And but you can publish your rules directly to a stream and then consume that stream from elsewhere if you needed to. You can also call serverless functions from a cloud event. So again, like I said earlier, when we were looking at autoscale, schedule-based autoscaling, the schedule-based autoscaling event will fire a cloud event, and you can call a serverless function as a result of that cloud event being fired. What services produce events? I think the better question would be, what services do not produce events? And the answer to that question would be none of them. As far as I'm aware, pretty much every single service in the Oracle Cloud will produce cloud events. There may be just a few of them related to that service, but they all fire cloud events. I'm sure someone will correct me and tell me that I'm wrong about that, but as far as I'm aware, they all produce events. So how do you do them? How do you do them? How do you create them? Well, you go into the Cloud Events console dashboard, you click Create Rule, you give it a name, and you create some conditions. So in this case, like I said, object storage has the ability to listen for when an object was created. So you select event type. You select event type, as you see here. You select object storage and then the event type. So all your services will be listed in that middle drop down, and the event types are all listed in that third drop down. Now, there are so many events that are available just for object storage. There is a bucket created event. There is a bucket deleted event. Pretty much every type of action you could take on every type of resource within a service will produce an event. So in this case, we want to know when objects are uploaded to a bucket. And why do we want to know about them? Well, if we look down at the bottom for the actions, we want to take an action based on that. So in our case, we want to call a serverless function. So we can select action type of functions, the compartment that our function resides in, and the application and the specific function that we want called when that event happens. What happens with serverless integration is your serverless function will receive as an argument a JSON representation of that event. And this is like I said, a CNCF standard format that is received. Depending on the language used, there are SDKs available. I know for Java, for example, there's a CNCF I don't know if it's actually CNCF produced or supported, but there is a Java package that defines a POJO for the cloud event object. So if you type this Java incoming argument as a cloud event, you include that dependency in your serverless function, it will be all ready to go inside of your function. Let's talk about object storage. Now, I said object storage is a very familiar service, and of course it is. This is probably one of the very first services that you've ever used in a cloud, but there are some hidden gems in object storage, and there are 5 of them. Let's talk about them. Versioning, pre-authenticated requests, lifecycle policy rules, replication policies, and retention rules. So versioning is does exactly what you think it does. You may not have known that it existed or even possible. When you enable versioning, every time your object changes or is deleted, a new version is created. Now, you cannot disable it once it's enabled. It can only be suspended, but it is a nice way to track the versions of an object in your object storage. The most recent version obviously will be the one returned unless you utilize the APIs or the UI to retrieve a very specific version. But in general, if you want if you call get on an object in a bucket with versioning enabled, you're going to get the most recent version. Now, if the object is deleted, there will be a deleted version created, but you can't retrieve it because it's deleted. So if you go to the UI or if you look at it through the CLI or SDKs, you'll see that there is a deleted version of the object, and it's just a placeholder for the fact that the object was deleted. Pre-authenticated requests. I hope, and in fact, by default, when you create a new bucket, it's usually, well, it's always going to be created as a private bucket by default, unless you have overridden that fact. And most of the time, this is exactly what you want. I mean, if we all remember back a few years ago, there was quite a lot of noise made around the fact that a certain other cloud provider had been exposing a lot of buckets in their version of object storage and were leaking all kinds of really information that really shouldn't have been leaked. So by default, all your buckets are created private. And that's a good thing. Like I said, security is definitely should be the default. Now, what happens when you have a private bucket and you have a lot of objects stored in that bucket? And let's say the project manager for your application or the client or someone really important says, hey, I want to take a look at that file that so-and-so uploaded on May 5th. Now, you may have built a way to retrieve this file within your application and let them search for it like that. But a lot of times, in my experience as a developer, that happened through an email or a kind of a one-off request. And you would need to provide a URL for that person to download that file. Now, you could download it yourself, host it somewhere else, and provide that URL. But a nice thing to do here is create a pre-authenticated request. You can do this either for a bucket or an object, and that allows you to set an expiration date and time for that request. So let's say the client asks you for a copy of a video file from 2007. You could provide that URL. You can say, here's your URL, please download it by 5 p.m. Otherwise, this URL will expire. And it's a one-time, well, it's not a one-time, it's until the URL expires. I mean, obviously, it is insecure because it is a exposed endpoint for that object, but it's kind of working on a security by obscurity model. You know, it's going to be a unique URL that's insecure for a short period of time, but there are cases where you need to use it. I probably just spent way too much time talking about pre-authenticated requests. Let's move on to lifecycle policy rules. Now, I use this a lot in my demo buckets because there are a lot of times where I create demos and I upload a bunch of files to it, and at the end of the presentation that I'm giving or the webinar that I'm giving, I no longer have a need for those files. So what I do is I have a bucket that I use for my demos, and I have a lifecycle policy rule that says after 3 days, delete everything in this bucket. I don't need it anymore. Now, this could apply. You can also use this for archiving. So let's look back to an example of an application that I worked on a few years ago that involved a lot of uploading of data for application purposes. And it involved videos and resumes and things like this. And after the current year, when all of the judging was made on this particular application, we no longer had a need to keep that data in active storage. We can move that over to archive storage because it wasn't hardly ever touched after that, but for retention purposes, we needed to keep it. Now, archive storage is obviously going to be a lot cheaper than regular storage, so we took advantage of that feature and moved everything to archive storage after a certain amount of time. So really nice way to do that is to set up your lifecycle policy rule after a certain number of days. Now, this is object specific, I should mention. So after 30 days after the object is created, the rule will apply. This is obviously not, that date is not applicable to everything. It's only applicable to new items after the date they are created. You can do some filters on it, some basic filters, like as you see at the bottom of that screenshot. If I just wanted those files that began with a certain prefix, let's say maybe they were uploaded with a timestamp, and maybe I want it after a certain year, we could filter it that way. Replication policies are a nice way to create a read-only replica of an object in another region. So when would you do this? Let's say, for example, a very simplified example, you have a corporation in the United States. Let's say you had half your employees on the East Coast and half your employees on the West Coast. And again, just to simplify things here and pretend like this use case is actually valid, let's say that the people on the East Coast have a lot of latency when they try to download files that are stored in the bucket on the West. Well, you can set up your service to basically create a read-only replica of all the files that hit that bucket in another region when they're uploaded. So read more about that at the link below there, but it can be a very handy feature, especially if you're globally distributed, your audience is globally distributed, and you need to keep read-only copies of objects in other regions. And again, that could be for data archiving purposes if you need it to be, or for data disaster recovery purposes, I'm sorry. Retention rules are used for regulatory compliance, data governance, and legal holds. You can create a retention rule that can be time-bound or indefinite, and you can specify the duration of that retention rule. So this will keep files from being deleted within a bucket. Now, there are some caveats as it comes to retention rules. Lifecycle policies can archive objects with retention rules. Archive. Lifecycle management cannot remove objects that are protected by active retention rules. So let's say you created a rule to delete objects after 3 days. That obviously that management policy will fail if there's a retention rule. And you can see the other caveats here listed here. And if you need to know more about that, please refer to the docs. Let's talk about the autonomous database. The autonomous database is awesome. There are some features that you might not be familiar with when it comes to autonomous database, and we will look at each of those individually. First of all, Performance Hub. You may or may not know, at a quick glance within the console UI of the Oracle Cloud, you can take a look at the activity, CPU statistics, some basic SQL monitoring, all of this stuff at a quick glance, filterable, somewhat searchable, directly from the console UI. It's a really nice way to just get a glance at what's going on in your autonomous database. The Service Console has links for all kinds of really awesome tools that are all available absolutely free as part of your autonomous database instance. You can download instant client libraries and SDKs if you needed those. SOTA drivers. SOTA is Simple Oracle Document Access. It's this NoSQL style set of APIs for using collections of JSON documents in a Oracle database. So it's a really basically a NoSQL-like experience, persisting and retrieving JSON documents directly in Oracle database. There are libraries for Java, Node.js, Python, etc., and you can download those directly from the Service Console. SQL Developer Web. Hopefully you know about this, but again, this could be a super hidden gem for you. SQL Developer Web is a browser-based IDE that is basically a browser-based version of SQL Developer, the desktop application. Now, it's just a subset of the features that are available in the desktop product, But if you needed to run some queries, make some simple changes, look at an execution plan, things like that, all available directly from the browser, no install needed. So if you're on the go or you needed a quick look at something, or even just a way to run some quick queries against your autonomous database, you can do that directly in SQL Developer Web. Apex, a low-code application dev framework for building and deploying data-centric applications, is the term that they use. To me, it's basically a WYSIWYG kind of system type drag and drop type system for low-code app development, all available completely free with your autonomous database instance. The best way I like to think of it is, at least for someone who's very developer centric like myself, if you're ever tempted to pass around a spreadsheet to multiple people within your application because you didn't want to take the time to web base it, you should definitely change your mind and use Apex instead, because you could import that spreadsheet, you could browser base it, add some validation, add some basic versioning support instead of passing around spreadsheets, and be done with it. You can have that all done for free, persisting to your Oracle Autonomous Database right out of the box. Machine learning notebooks and Oracle REST data services, again, also free, also available with your Autonomous Database. Here's a quick look at SQL Developer Web. Should be familiar if you've used SQL Developer at all. You can run your queries right from your worksheet, see your results right below, introspect your tables, all of that good stuff directly in there. Here is what Apex looks like. You have your app builder, you have a lot of documentation right built in, and you have this gallery of applications. So sample apps that you could deploy directly from Apex to kind of get an idea of how things work and what it looks like to work with Apex. Machine learning notebooks, these are all available again for free. You can build your queries. There are tons of examples that are available to you to show you, for example, against sample schemas, how to run certain types of different machine learning routines against your data. So you could do, for example, a linear regression against your data set. You could train, test your data set all directly from the Oracle machine learning notebooks. Oracle REST data services. If I had another 2 hours with you, I would talk to you about this for one of those hours because it's so super awesome. What you see on your left there is a way to REST enable a schema and a table. And there are a few additional PL SQL statements that you have to run, 3 or 4, to create an OAuth client and things like that. But once you run those and you get those all done, you have what you see on the right. You have a full set of REST endpoints that can be called with basic HTTP, and you can pass back and forth JSON representations of your objects and your tables. Now, this is a really nice way to interact with your autonomous database without using JDBC or any of the other client libraries that you might need. If you're using Go or Python or whatever language you're using, you can expose, because every language speaks HTTP, right? I mean, you could even call these directly from curl or Postman and interact with your database table that way. So again, completely free, available with your Oracle Autonomous Database, all hosted for you. SODA, Simple Oracle Document Access, talked about this a little bit. And again, it's this NoSQL style set of APIs. The first 3 lines here are what you use to establish a connection and create a collection of JSON documents. And then on line 4, you simply call insert one and get, for example, to create a new object, passing a JSON representation of that object. All of the traditional familiar type operations are supported: removes, updates, retrieves, lists, searches. All of those operations are supported with SODA. Let's talk about Resource Manager. Now, I included this in here, and when I made these slides about a month ago, and I didn't know much about Resource Manager, to be perfectly honest with you, until this week. And I've spent a lot of time this week, ironically, on a for other purposes, for another project, learning about Resource Manager and the capabilities and power of Terraform on the Oracle Cloud. If you're not familiar with Terraform, it is, if you've ever heard the term infrastructure as code, and that is not infrastructure as cod, as some people say, but it's infrastructure as code. And basically, what you can do with Terraform and infrastructure as code is you create a code-based representation of the infrastructure that you would like to either deploy or update or alter or delete in your Oracle Cloud. Now, this OCI Oracle Cloud provider for Terraform provides this domain-specific language for creating and working with all of the different resources in the Oracle Cloud. So you can create this code-based representation of your infrastructure, and you can deploy it as what's called a stack. Now, the stack is can consist of multiple operations. So, for example, the one that I'm working on right now has it creates a VM instance. It creates an autonomous database instance, it creates the network, it creates a vault, it creates a key within that vault, all of these things. And you deploy the stack, you can test it before you apply the stack, but then ultimately you apply the stack and it creates all of these resources for you. Now, the really awesome thing about it is you can also keep it in sync with your environment, perform diffs against your current environment to make sure that that stack is still relevant. And then ultimately, if you needed to, you can destroy the entire stack with a single click of a button. So I encourage you to look more into it if that sounds like something that you would be helpful to you, and take a look at the documents down below. Here's just an example of a stack and the different jobs that are that I've run against that particular stack. Let's talk about monitoring. Now, monitoring is, maybe somewhat of a boring type topic, but it's very important and it's very crucial that you be able to keep an eye on the health of your resources in the Oracle Cloud. So with monitoring, you can view your service metrics. You can create or view alarms. You can integrate with Grafana, which is a really nice application for viewing all of your charts and different resource metrics in a nice web-based view. And you can create, the two things I want to talk about are the bottom bullet points here. You can create health checks and you can use custom metrics. So let's talk about health checks. What is a health check? Well, a health check is a way to check that a service is healthy. As funny as that sounds, it's exactly what it sounds like. And so to create one, you give it a name, you choose a compartment that the health check will reside in, and then you choose the target. So in this case, I'm checking my personal blog, which is at recursive.codes, and I'm using a vantage point of AWS East US 2. So these are externally hosted to make sure that they're, it's not reliant upon a particular Oracle Cloud region. So in this case, we're using the AWS East US 2 region. So the next thing we do is we specify the frequency that we want that to run and the type of request that we want to make, the protocol, the port, things like that. We can add headers if we needed to, and we could choose the HTTP method that we want to use to check that URL. So once we've defined all these things, in this case, every 5 minutes or every 10 minutes, this health check will run, and you will have a complete history of all the various requests against that URL. Now, again, this integrates with Cloud Events. If you wanted to get a text message when if you check every 5 minutes, you want to get a text message or a PagerDuty alert if your URL is not returning a 200 OK, you could easily do that. And again, these integrate all with metrics, so you could view a history of the response codes and the DNS lookup time related to the requests, as well as several other metrics. And custom metrics. So what is custom metrics? So metrics, you have in the Oracle Cloud the ability to, as I've said many times, check on existing things like CPU utilization of a VM, disk space usage of a VM or a database, things like this. These are all metrics that you have available to you. Custom metrics gives you the ability to produce your own metrics and group them and filter them and do these sorts of things. And once you create and produce all of these metrics, you can view those directly as you would any other metric. So for example, we see here the health check metrics on the previous slide. If you use custom metrics, you could get these same type charts and you could slice and dice that data any way you needed to and view them directly within the metrics viewer on the OCI dashboard or again within Grafana. So let's say you wanted a produce your own metrics for whatever, orders per hour, these types of things. You could produce all these custom metrics and publish them to the OCI cloud and slice and dice them, download them, filter them, anything you need to do with them from that point on. Let's quickly talk about vaults and secrets. So vaults and keys are nothing new. They've been part of the Oracle Cloud for quite some time. What is new though is secrets, and secrets are a really nice way to store sensitive data and really probably the only way you should be storing things like passwords and API keys in your Oracle Cloud. So you want to create a vault, you create a key, and then once you've done that, you can create secrets within those vaults that are encrypted by the key that you create. Now, once you've done this, you can then get these and retrieve these just based on the secret OCID, retrieve those and decode those directly within your application. So no more storing passwords or API keys in configuration files. These can be securely stored in an Oracle Cloud Vault, encrypted by a key, and retrieved and decrypted at runtime within your application. Really nice, really handy, and you should definitely be using it. OS management, we're gonna fly quickly through this, is a way to manage your VM software packages, updates, installs, and schedule installs and updates to keep your VMs up to date. Now, it's a way basically to manage all the software installed on your VMs. You can group like VMs, for example, VMs that are all running Oracle Linux 7.1, for example, or all running Windows version whatever. You can group these, and that allows you to apply software updates every Monday at 4 a.m., for example. You could schedule them, view available updates, you can search for and install packages, additional packages on these, and you can schedule that install as well. All of this directly through the console UI directly within the Oracle Cloud. There are many things. We are at 48 minutes here, but there are many things that I would have loved to include but just did not have the time to include today. But we did talk about a ton of things. And again, I hope that you have learned something new. All of the links for all of those items that we talked about are here in this, and I can publish these. If you want to follow me on Twitter at Recursive Codes or connect with me up on LinkedIn, and I will be sure to post the slides later on. Again, my blog is recursive.codes. I blog quite frequently on the Oracle Developer blog, and you can read all of my awesome stuff there. If you want to contact me, again, Twitter, LinkedIn, or you can email me, todd.sharp@oracle.com. I thank you for coming, and I invite you to share with me your favorite feature that you learned about today, and ask me any questions you need to ask me, and we'll go to the chat now to take a look at some of the Q&A. All right, let's look at the Q&A here. So does Oracle Integration Cloud generate events as well? What is the other services include? That is a good question. I know that Oracle Integration Cloud does integrate with serverless functions. I do not know for sure whether or not it produces events, Julio, but I can follow up on that if you email me, todd.sharp@oracle.com. I can follow up on that and we can talk about that offline. Julio has another question. Why isn't there an Oracle Functions channel in Cloud Customer Connect? I hate to say it, but I'm not familiar with Cloud Customer Connect. So I don't know why there isn't an Oracle Functions channel, to be honest with you, but I will look into what Cloud Customer Connect is and see why there isn't an Oracle Functions channel. I know the Oracle Functions team well. I know a lot of the project managers and a lot of the engineers, and they are awesome people who love to help, and they are very proud of the service that they have built and have done an amazing job with the service that they have built. So I'm sure they would be more than willing to help you out with any queries that you have. Can I write to the streaming service from OICS and use it as a queue? Now, I know, again, that you can integrate with functions, and I believe that you can use REST APIs from Oracle Integration Cloud. So if you can use REST APIs, then you absolutely can use the streaming service from it, because there is a full set of endpoints. The other option is, if you don't want to use the Oracle SDK or the REST APIs for the streaming service, like I said earlier, you can use full Kafka support. So any Kafka client that works with Kafka normally, you can configure it to work with Oracle Streaming Service. Can Fusion ERP HCM write to streaming directly or only through OIC? I am not, unfortunately, I'm more familiar with the OCI services than I am with things like Fusion. But again, please, Julio, email me all of these questions and I will find the right answers to you for you. Another couple questions from Julio. Which IAM policies are needed to give a group in OCI access to notifications and events? These are all listed in the documentation. Every service documentation, if you go, the thing I do a lot is you go to create a new, for example, a new topic in OCI in a notification, and in the top right-hand corner, there's always going to be a help link. Click that help link, and pretty much everything related to that service will be, you'll be taken directly to the documentation for that, and the relevant IAM policies will be listed in every service. I promise you that they are all listed when you go to that help doc. Can I create a health check to an OIC or VBCS URL? As long as it's web accessible, publicly web accessible, you can create a health check for it. Another option, like I said, like I showed you, is you can add headers to your request. So if you need any specific headers to be added to a URL, but as long as it's web accessible, you can add a health check to it. Okay, I don't see, wait, there is some QA in the QA channel. Let me look at that. Can I send serverless functions log to Splunk? If it is a socket server that supports, that gives you a TCP URL, then you absolutely can send. I'm not familiar with Splunk, so I do not know if they offer that. But if they offer you a TCP URL, you can absolutely point functions to it. Can we create rules from events coming from a SaaS application? Again, I think this pretty much is the same question as can OIC generate events? And the answer to that is I'm not sure. But I will find out. If you email me, I will reply to you. Where can I find this deck, Eric? As I said, I will publish it probably on LinkedIn or as well as Twitter. And I do have a page on my blog, recursive.code/presentations, and I'll put it up there as well. Venkata asks, Oracle SaaS Cloud. Okay, I believe Venkata is answering for me. Oracle SaaS Cloud currently don't generate events for all the objects of interest. Is there any reference architecture of how this can be achieved using events and functions? I don't believe that you could produce custom events from the API, but you can use notifications almost in the similar fashion from your application. So if you have a SaaS cloud application and you can call REST APIs from that, and you can use the Oracle notification service REST API, then you can use notifications just like you would use events. Basically, you publish a message to a notification topic, which can call a function itself. So you can kind of roll your own event type system like that, but I don't believe you can produce cloud events per se directly. If we are to design our own SaaS product, do we have any guidelines or reference docs which can help on how to make use of Oracle IaaS to achieve this? That I don't know either. I could just recommend that you become very familiar with the Oracle REST APIs and the various SDKs that we offer, because everything that you can do via the console can be done via the CLI, via the REST APIs, via the SDKs. So if you become very familiar with the SDKs and the REST APIs, and you can call those from your SaaS product, then you can absolutely do anything you need to do in the Oracle OCI cloud with any IaaS product or service. Every operation is supported on all of those platforms, all those tools. So you can absolutely integrate to your heart's desire with those SDKs, APIs, and the CLI. So that's all the questions. Oh, wait, let's see here. Julio says, in response to someone else's question, you can use the event collector endpoint in Splunk to receive those notifications. Awesome. There's also a functions adapter that writes to the Splunk event collector. Thank you very much, Julio, for sharing that information. I appreciate you all for coming. Again, please share with me what you found most interesting today. Interact with me on Twitter, twitter.com/recursivecodes. Follow up with me via email. I am here to help you out. And I look forward to seeing you next time. Thanks again. Thank you, Marcy, for having me. I appreciate it.